Students, this question was asked in the year 2015 in NEET exam from the chapter Units and Dimensions. If dimensions of critical velocity Vc of a liquid flowing through a tube is expressed as eta to the power x, rho to the power y, r to the power z, where eta is the coefficient of viscosity, rho is density of liquid, and r is the radius of the tube, then values of x, y, z are which among the following four given options? Okay, student, Vc is given as eta to the power x, rho to the power y, and r to the power z. And this question is asked from dimensional analysis. We have to find out the dimensions of the left hand side, that of the right hand side, and compare both of them to get the values of x, y, and z. Okay, students, what is the dimension of critical velocity? This is a velocity, and we know velocity is equal to length by time, the distance traveled or displacement per unit time. So student, this is Lt to the power minus 1. And let us find out the dimensional formula for eta. Stokes law, you have already studied, students. Stokes law. What is Stokes law? Stokes law states that the viscous force on a ball 6 phi eta r v. A ball which is moving in a viscous medium which has a radius r and with velocity v is given as f is equal to 6 pi eta r v. From this equation we know, student, eta is equal to f by 6 pi r v. And what is the dimensions of force? That is mlt minus 2. And what is the dimension of 6 pi? This is a number, so it is dimensionless, or its dimensions are m0, l0, t0. And what is the dimensions of r, student? That is length. And dimensions of velocity v is l t to the power minus 1. So the dimensions of eta will be, students, mlt minus 2 divided by lt minus 1. This l cancels out, and this becomes m l to the power minus 1 t to the power minus 1. Okay, student? Then we will write it here, m l to the power minus 1 t to the power minus 1 to the power x. What is density, student? Density or mass density is given by the formula mass per unit volume, you know. And what is the dimension of mass, student? That is capital M in square bracket. And what is the dimension of volume? We know that is L to the power 3. So the dimensions of rho is ml to the power minus 3. We will put it here in rho, ml minus 3 to the power y. Okay, student? Then what is the dimensional formula of r? R is radius, so it is a length. So student, it has dimensions L to the power z. Okay, student? So this will become an expansion m to the power x, L to the power minus x, t to the power minus x, m to the power y, L to the power minus 3y, and L to the power z. Okay, students, this will become m to the power x here, m to the power y here, x plus y, and L to the power here minus x, here minus 3y, and here z. So this will be minus x minus 3y plus z, and multiplied by t to the power minus x, and there is only 1t. Okay, students, then let us compare the dimensions of left hand side and right hand side. Here, what is the dimension of m? There is no m, so we may write n0, l1, t to the power minus 1 in the left hand side. Okay, students, then we know from the principle of homogeneity of dimensions, the exponents of mass, length, and time, or the dimensions of mass, length, and time in both the sides of the equation must be equal. So what is the dimensions of t here, student? That is minus x And what is here in the LHS? That is minus 1. So minus x is equal to minus 1 or x is equal to 1. Okay students? Then x plus y, here m has exponent x plus y, here in the LHS it is 0. So x plus y is equal to 0 or y is equal to minus x is equal to minus 1. Okay student? Then what is z? Z minus x minus 3y plus z minus x minus 3y plus z is equal to how much? Here 1. So z is equal to 1 plus x plus 3y is equal to 1 plus what is x? X is 1 plus 3 into what is y? Minus 1. This is 2 minus 3. So this is equal to minus 1. So the value of x we found 1. The value of y we found minus 1. The value of z we found minus 1. So 1 minus 1 minus 1 will be the answer. Where is it? 1 minus 1 minus 1 in C. So the option C is correct, students.